Monday and Tuesday morning. I mean, Monday and Tuesday's class. And do you want me to send you like a note to remind you to tape it?
Yes.
What's better? The
Message.
just message you. I mean, through the school site.
No, to get to the My Open Math.
On My Open Math. Okay,
Yeah.
I will do that. Remember to record today.
I did start today. I did.
Good.
But yeah, I haven't been lately. Not for any particular reason, just because I've been fearful.
Yeah.
So, got a couple problems for us to start with today. I got this one. And
if those are any of the ones that I sent you, I figured them out. I just want you to know.
Well, that's good, but we can still look at them, right?
Okay.
Yeah.
I usually figure them out like right after I send them to you.
It's surprisingly common, actually.
I think it's just my higher powers like saying you should surrender, and so I surrender and give you the question, and then it's like, okay.
And then the brain can relax, and it goes,
Yeah.
oh, but by the way, this is how you do that.
Figure it out.
Yeah. Let's see. Well, let's do that one too, just because it's super straightforward. So I want to give you guys a couple of minutes to play with these, decide what your answers are or should be, and then discuss them. I'm going to put one more up there real quick here. Do that. Okay, and if it would help, we could call it like a quiz or something, if that would help you, like, emotionally.
Do we get extra points for it?
No.
Then no quiz. Are you saying that so it gets our brain in like quiz mode and then we remember things? Well, so like a psychological thing?
Right.
Okay.
Okay, I'll stop that. 4 questions.
The binom problem.
Who likes a good flow chart? Michelle likes a good flow chart. Isabel doesn't like flow charts. Kim likes flow charts. Rory, I can never tell because he just gives me a stern look all the time, every day. Just, but that's okay.
Standard deviations.
40.3. Oh, no, 2 does. So Matt, is the second question a binomial question?
It is indeed.
Haha.
Aha!
I know it took me a second too. I was like, no, no.
I think I got
What
it.
we're doing. I've done this.
Tried to trick us.
Tried to teach.
Yeah, no, it's good. I'm glad you did.
That is good because
One of the things that can be really helpful, particularly using your textbook, because your textbook has, of course, a lot more problems in it than the homework does. One of the things that can be really helpful is to look through the homework problems. Say there are 30 questions on that homework section in the end of your section in your textbook. Doing all those 30, it would take quite a while. It's certainly a reasonable use of your time, but it does take quite a long time. But one of the nice things to do with those 20 problems or 30 problems or whatever is to go through each one and just identify what type of problem it is. So I would, like on this problem, I would use this tool, and this problem I'd use that tool, and this problem I'd use that tool, and get that kind of reinforcement of this idea of looking at, okay, what type of problem is this? What tool would I use? Okay, what type of problem is this one? What tool would I use? Because oftentimes when we work a small number of problems all the way through, we make that decision about what type of problem it is. And then we spend, 5 or 10 minutes working on the problem itself and getting into the mechanics before we look at another problem. So we don't get a lot of that reinforcement of making that, kind of initial decision. So oftentimes kind of focusing some practice on just identify type, identify type, identify type can really help when you start something like a test or a quiz or even just the normal homework problems, making that good initial assessment of what type of problem is this, what tools am I going to bring to it. Does that make sense? So focusing on that practice and just going through and making that decision on a bunch of problems without spending the extra 5 minutes on each one to actually do the problem can help focus that practice on that key skill of what type of problem is this, what tools do I bring. So keep that in mind when you're looking at practicing this stuff. Because oftentimes for these problems, once you know what type of problem it is and what kind of question you're doing, then you're just plugging stuff into stuff. So any questions about the identifications that I've done here on what I think these problems are?
Oh, I like that chart.
And we'll actually expand this when we get to chapters 8 and 9, expand this chart, quite a bit, but it'll start with these first choices. Is this binomial? Is this continuous? Then is this a normal distribution problem? Is it standard distribution? Kind of breaking this down. So starting to kind of think, whether you write this flow chart or not, starting to think like this kind of flow chart is going to be helpful, I think. So, you guys want another couple of minutes to play with these, or do you want to talk through them?
I think I got it.
And nobody else has a thought?
Yeah, I think I'm ready to talk through it.
So, let's see. We're a bunch of thermometers. We're told normally distributed. So normally distributed is one of those key words that's going to make us think this is a continuous problem. We're told a mean of 0 and a standard deviation of 1. And that mean of 0 and standard deviation of 1 means this is also even standardly distributed automatically. We don't have to go to z-scores or anything like that, which is kind of fun. Temperature reading separating, we asked for the temperature reading that separates that bottom 65 from the top 35. So that's that 63rd percentile. So we're asked for a particular proportion and we want to know a value. That's what identifies it as an inverse question, because we're given the percentage and we want a value. That is the key to knowing it's an inverse question. We're given the percentage, we're given a proportion, the 65th percentile, the 65%, and we want to know what is the value that separates it. Fair? So that tells us it's got to be an inverse. So we want this line that's going to separate the bottom 65% from the upper 35%. We want that value. Fair? Now, if we were doing this the way we did them yesterday, we would grab our table. We'd look for that 0.6500 or as close as we could find, and we would look for its z. Right?
Right.
But we were going to start learning how to use the calculator for this stuff today, right? Or Excel, but we'll focus on calculator today and Excel tomorrow. So you have a tool in your distribution menu, the same distribution menu where you give the CDF and PDF for your binomials. So you should have a command in there for inverse norm. So make sure you can find that. And that inverse norm wants the proportion. It wants the mean, and it wants the standard deviation. So for this particular problem, we're going to go inverse norm. We're looking for that 0.65, so 0.65. We have a mean and a standard deviation, which is going to be especially handy when we have problems that aren't 1 and 0, but we have a mean of 0 and a standard deviation of 1, and that should throw us back a value. What do you get when you ask for that value?
0.3853.
0.3853. And hopefully that should seem reasonable. There's a value of 1 there, 0 there, -1 there. This is 50% below the 0. We know if we go out to 1 standard deviation, we're adding 34, so that would be 84%. So it had to be less than 1, but still positive. So 0.38, almost 0.4 in scale seems very reasonable. So what temperature reading separates the bottom 65 from the upper 35? A temperature reading of that 0.34, or sorry, 0.38 or 0.39 if you want to, depending on how you want to round it.
Yep. Got that one.
Okay. So, if you did it in the table, your table, you would have had the 0.3 there and roughly the 0.08 or 9 there, depending on how close you could get on the table. But it's nice to not have to use the table, right? Notice, is drawing the diagram still helpful, even if we don't use the table? So like draw the diagram, right? Okay. Questions about that problem? Okay. You guys were absolutely right. The second one is a binomial question. We know it's a binomial question because we're talking about, people preferring candidate A or not. So we have that yes or no. Do you prefer yes versus no? So we have that binomial yes or no and a percentage of that happening. Also, we're talking about the probability of a number of successes, a number of yeses in a particular number of trials. So it's giving us an N and an X. We're asked for the probability that exactly 13 of the 19 voters, not more than 13 or less than 13 or at most or at least. So we're asked for that specific probability. So that tells us this is a PDF problem, a probability distribution function problem, not a cumulative problem. That should give us the expectation that that probability should be fairly small. Individual probabilities tend to be on the smaller side. I mean, it could be as much as 20% or so, but they don't tend to be 90% or 80%. They tend to be fairly small. So having that expectation going in is nice. But the nice thing, we know how to find binomials. We've been practicing that. So binom PDF, we just have to either have that nice chart if we've got like a TI-84 or whatnot, or remember the order that they have to go in. You guys remember the order they have to go in? What is it?
To go all of them, the 19, and then the percent, and then the exact one.
So good old NPX.
Yep.
I often remember that because they're technically in alphabetical order. So, Binom PDF. 19 trials, a percentage of 54%, and we want to know about the 13. The order in Excel was a little bit different, but the nice thing about the order in Excel is it told you what they were. So I think it's NXP and then cumulative or non-cumulative. Anyway, either way, what do you get?
0.0853.
0853.
Yep, that's what I got.
So about 9%, depending on how much we round. And again, as a PDF, as a single percentage, we expect it to be fairly small. And that's fairly small, so matches that expectation. Not a tough question, but if you're trying to do it with our Chapter 7 tools, it would be an impossible question. So again, identifying type and tool is often the biggest issue with these problems. So our third one here has no context. It's not a word problem. Sometimes that lack of context makes the problem more difficult because find standard normal distribution, find PZ less than 2.02. It's like you got nothing to work with. There's no feel to it, and that can often make it more difficult. But standard normal distribution means the normal distribution means the bell-shaped curve. The standard means our mean is 0 and our standard deviation is 1. So that standard normal tells us it's continuous data, tells us it's bell-shaped, and tells us our mean standard deviation. So there's a tremendous amount of information caught in that word or phrase, standard normal. The problem with the thermometers told us our mean was 0, our standard deviation was 1, which technically means it's already a standard distribution. But they told us what they were. Here in question 3, we're not being told there's 0 or 1 directly, except for the fact that we're told it's standard. And if it's standard, it's mean 0, standard deviation 1. CDF, because we don't do a PDF for continuous distributions. You can, there is a meaning for it, but we won't be doing it. It's the height of them, so it's the individual probabilities over a given distribution length. So we can, it is a tool, but it's not a tool that we're going to use. So it's either like I have up here, it's either the cumulative CDF or the inverse. So this is a CDF, which CDF automatically does less than, and this is a less than question. So none of that 1 minus stuff that we have to do sometimes. If this was greater than, then we would have to do the 1 minus, right? So that's a good thing to remind ourselves. 2.02, so we want 2.02, so that's going to be out here, 2.02 for our z-score. So we expect that to be a fairly high percentage. We know, within 2 standard deviations should be 95%-ish, really close. So this is a little bit further than 2 on this end, and the rest of this tail on that end, so it should be in the high 90s. So again, having those expectations when we go in is nice. So again, we could look at our chart, and on our chart, we're not doing inverse. We have our z-score of the 2.02. So we could go to the 2.0 and then the 0.02 and find that proportion. Or we can grab the calculator. Now the calculator has a really nice tool. It's really nice in some ways, but also it can make you soft really fast. So do be a little careful with it. That normal CDF, it asks us for the low value, the high value, the mean, and the standard deviation. So that low and high means we don't technically have to use this tool as a value and down. We can tell it where to start and where to end. Fair? The tough part of that, other than the fact that it can make us really soft, because we even we don't even notice, we don't even have to give it a z-score. We give it the standard deviation and the mean. It figures out the z-scores. So we don't even have to standardize things when we're using this tool. Super wussy. But when we want either this low or high to be out towards infinity, it can get, well, I don't have a low or I don't have a high. So it can be like, well, what am I going to put? So in a problem like this, where our low should be, technically negative infinity, well, I can't put in negative infinity. So what are we going to put in instead?
-1 to the 10 to the 99th.
We could do that. -1 times 10 to the 99th power.
Or E.
Or you've got that button on your calculator that's EE. So like above your 6, I think it is, somewhere around there. 99. Now what's that going to give you? That's going to give you -1 with 99 zeros behind it. Okay, it's not negative infinity, but I'll keep drawing zeros for a while. Well, I'm not going to draw all 99 of them. But frankly, you could also just do something like, -9,999 if you want to. I mean, almost all is supposed to be -3, right? -4, okay, that gets almost everything. Even if we went -9, the difference between saying -9 and saying negative a lot down there, the difference between those is going to be negligible. Fair? So if you want to kind of say, well, how low could the calculator possibly go? Okay, -1 E, it's the EE button, but your screen, will only type one of the E's, 99. That's going to give you, essentially, as far as the calculator is concerned, negative infinity. But frankly, you put in, -100, and the calculator is going to go, okay, and give you almost the same response. Fair? So if you're comfortable with the EE, and again, this stands for -1 times 10 to the 99th power, scientific notation. But you'll find you get, fairly comparatively accurate values with, I usually put in 4. I don't know. I think your book likes 4. I don't know. And your book, of course, likes this a lot. So just, some negative, super, super large value. What's the high? The high, 2.02. So we want to go from that 2.02 all the way down forever. But, again, that's 3. that's 1, that's 2, that's 4. You know, how much is down here by the time we get to, these are negatives, of course. How much is down here by the time we get to even 9 or 10? Virtually nothing. So negative 999, plenty. With a mean of 0 and a standard deviation of 1. Anybody unhappy with this negative big number idea here? None of you look unhappy. Except Camille, she left. Negative 99.99. I'm out of here. Oh, she's back. Okay. So, what do you get?
For the last answer?
No, for the third one, for that normal CDF.
0.9873.
And again, we expected high 90s, so that seems reasonable. Did anybody, instead of putting the 9999, put in the negative 1 e to the 99th? Like, so Andrew, was your answer to 4 decimal places different?
I actually got 0.9783 instead of 0.9873.
Just smaller?
I got the same thing as Andrew.
I might have dyslexia wrote it backwards.
So 9783 instead? You say? Okay. So
Yeah.
the answers there. That happens. So, and that answer, you got that answer if you put in the 9999. You got that answer if you put in the negative 1 e to the 99th. Anybody put in just something like negative 9? If not, try that. See if you get anything different. You know, it will be different, but whether it's different to 4 decimal places, I doubt it.
Yeah, it doesn't even look different on here.
Yeah. I wouldn't be surprised. I was kind of curious how much we can push this. What if you go negative 5? I wouldn't be surprised if it's still the same before.
Yeah, negative 5 is still the same to 4 decimal places.
But it's a little bit different at like 5 or 6 or 7. Yeah.
Yeah.
So this is supposed to be big negative, but you know, it doesn't have to be negative 100 billion quadrillion zillion. You know. So
Checked it on the chart too.
that worked on the chart too.
Yeah, and it's
Nice.
the same.
Okay. So questions about that tool? It's a nice tool. It's a particularly nice tool when we've got questions like this number 4. Because on this number 4, you know, still, again, we've got our standard normal distribution. So that standard normal says we're 0, 1, negative 1, and so on. But we want to know, let's see, the area or the percent or the proportion. Either way, we want to express that. So the amount of area, the amount of percentage or proportion between a z of negative 0.53. So a z of negative 0.53 and positive 0.53. So we want that area. So it's a CDF problem because, again, we've been given values and we want proportion or percent. So that's our normal, that's our typical direction, that's our forward direction. So that's our CDF type of problem. So we've got a high and a low. We've got a mean and a standard deviation because we're told it's our standard normal distribution. So that's just our normal CDF. We're told the low, don't forget the negative. We're told the high. We know the mean and the standard deviation. Then enter. What'd you get?
0.4038. Or 39 actually if we round.
But if you do it on the chart,
Yeah, I did it on the chart.
um,
And the
point
chart's fine.
8,
Yeah.
When you do it on the chart,
it's not as accurate.
you're going to take from, oops, now I have to change colors. You have to do from the 0.53 all the way down, right? And then you've got to do from the negative 0.53 all the way down. And what do you have to do with those couple of values?
Subtract.
So that would be z less than 0.53, and then subtract your p z less than negative 0.53. And what did you get then when you use the chart?
I got 0.4038, and so move it 2 decimal places is 40.38.
Yeah, me too.
And with the calculator, when you round properly, the calculator actually gives you 0.39. Are those the same answer?
Not according to open math, my open
No.
math.
Yeah.
But functionally,
But-
they're trying to be the same answer, right?
Right.
Which one's more accurate?
Calculator.
The calculator is more accurate because it's not, trying to round on that chart. When you're doing the subtraction, you're taking your roundings and you're subtracting your roundings, so you're approximating approximations. Fair? It's a nice, quick tool. If we only cared about, 40.4 versus 40.4, they'd be exactly the same. Fair? So getting, an answer within, a 10,000ths when you use the chart, that means you use the chart right. The chart is an approximation tool. Heck, even the calculator answer is an approximation. It only goes out on your screen to 9 or 10 decimals, depending on which calculator you have. In the background, it carries 27 decimals, which is nice, but it's still a 27 decimal approximation for this stuff. If you use Excel, it goes out to 125,000 decimal places, which is just silly, frankly. Like, because they could with no change in processing speed. But it's still an approximation. Yeah, it's 125,000 decimal approximation. Great, but it's still an approximation. So the fact that the table's like only approximate, it's all only approximate, just how approximate. So I do want to encourage those of you who are still kind of playing with the tables, work both the tables and the calculator. Working the tables and going through the z-scores and all that really helps kind of solidify what you're doing.
Yeah.
And what's going on and what you're finding. Particularly this normal CDF tool, high, low, mu, sigma, yeah, it can really separate you from what you're doing and what you're accomplishing. And that can be, make it harder to do problems when the problems start to get funny. So working the more hand tools can help a lot. But after a while, once you're kind of comfortable knowing what you're doing, there's the speed of being able to just normal CDF your problem is hard to argue with. Okay, let's throw out. Let's get a couple of slightly more contextual problems here. Yeah, yeah. So you guys might have picked up on today is mostly going to be kind of working through problems using our tools. We kind of went through the concepts yesterday. If any of the concepts are giving you trouble, let me know. This is the day to have those ask those questions. But turning our word problems into those questions and those ideas is kind of the goal today. So my intention is to mostly look at examples and make sure we're all happy. So take a few minutes, see how you would approach those. Curious about that. Oh, I haven't graded your hand in homework for chapter 6 yet. I will go in and do that. All right. So yeah, it looks like only 2 or 3 of you have really gotten into this homework assignment yet for 7, 1 through 2. Okay, that's not unreasonable. Yeah, as you do go through those, I really want to encourage you guys to do kind of a mix of some with the tables and some with the calculator. You'll be really tempted to just do it all with the calculator because you can go so fast, but make sure it jives with what the table is doing.
Oh,
Is this first one a CDF or an inverse?
To see, that's
An
a,
inverse.
Anybody want to argue with her or back her up? It's not your birthday anymore, so nobody has to agree with you.
that's what I got to.
Yeah, I think an inverse for that first one.
So we're given a proportion and we want to know values. That's our inverse. You're absolutely right. Nope. Just the INV. I don't write it out. I just look at the button. INV. Okay. And the order was P, yeah. P, mu, or X bar if we're doing a sample, and sigma or S if we're doing a sample. So, inverse. Three. Sigma 571. Sigma PT. That's just going to give us some answer. Anybody want to suggest what they got when they did with that, with that inverse normal?
I got 609.
Me too.
Wrong? Really?
I did not get 609. I got 541.15.
Wouldn't we not be using the 0.03 in there? We'd be using the 0.97.
Yeah. It's 0.97 that goes in there.
Oh, yeah, that's what I thought.
What did we not do?
You 1 minus the 0.03, you get
we didn't.
0.97.
We didn't draw the diagram, right?
No.
Where are the heaviest 3%?
Oh, yeah.
The heaviest 3% are right there. Right? The heaviest 3% are right there. So what do we actually want?
0.97, which is what the 609 goes.
Yeah.
Well, yeah, that's why the wrong was under this, not
Oh,
under that.
yeah. That part.
And this doesn't give that, right?
Oh.
Yeah.
This probably gives the 540 something, right, Michelle? I didn't say you were wrong.
Oh.
I just said what was written there was wrong.
Yeah.
And we know to do that because it says more than.
Well, it says heaviest, but yes, it says more than.
Right, or heaviest would mean more than. Yeah.
And we've talked about how important one it is to read.
It does say
Carefully.
more than
Does
in
it?
your thing. Yeah, it says heaviest 3%
Oh,
of fruits
the
weigh
heaviest way more than what? Okay.
That's
It
how
could
you
just say, the boundary for the heaviest 3%.
right. Well, heavy would mean a lot. Would mean
Yeah.
more, right?
Yeah. But I think it would be really easy in this problem to kind of go 3%. That's a P and throw it in, right?
Mm-hmm.
But it doesn't sound like I tricked you guys all that much with that problem. You guys are being smart.
I'm not going to tell you that I worked on that problem a few times before you just showed me it, though, either.
I'm not going to.
So I had a little practice,
Yeah.
Hey, I've said, how do we get good at things? We be wrong. Practice, be wrong, How can you tell which person in the wood shop is best with a table saw? Only got 4 fingers left. That person knows how to use a table saw safely. That's a horrible, horrible thing to say. In the United States, 10 fingers are lost to table saws every day on average. 10 fingers a day. Hopefully not on the same person. Table saws are very dangerous. Be careful of your table saw. Questions about this problem or table saws? All right. The country, United States. United States of Highlandia. Heightlandia. The height measurement of 10-year-old children is approximately normally distributed. Okay, so doesn't have to be perfectly normally distributed for us to use these tools. They're approximation tools anyway. With a mean of 56.9 and a standard deviation of 7.6. There's nothing formal about this, by the way. I often, do this to depict that one standard, deviation. It's just a way I started to notate it over the years. So that's just how I draw my diagrams. Draw your diagrams the way you want to draw your diagrams. What is the probability that a randomly chosen child has a height less than, again, we got to pay attention to that less than 75.6. So 75.6 is quite high in comparison to the mean of 56. So we'd expect it to be, certainly more than 50%. And frankly, that's a lot. The one standard deviation would be what, 64-ish. So another standard, that's a lot. So this should be somewhere in the high value, probably high 90s. And I really want to encourage you guys to do that, to kind of go and think to yourself, okay, what are my expectations? Should this be a big number? Should this be a small number? Because it's surprising how helpful that can be in identifying not only what tools you're going to use, but identifying if a problem came out, and you're like, oh, that can't be right. Let's see what I did wrong. Having that kind of expectation, this should be a large proportion. How helpful that having that expectation can be. But it's a normal problem. We're given our mean. And our standard deviation. we're asked for a probability or a proportion less than a value. So is this a CDF question or an inverse question?
PDF.
CDF, we're given value and asked for proportion. So absolutely, that's a CDF. So our tool, norm CDF, high low, what's our high low? What's our high?
Good.
60. Which one?
What's the high value for our heights?
It's 75.6.
75.6. Okay. What's our low value for heights?
The one minus, or the negative E99 or whatever.
Negative 1.
Yeah, E99.
What's our mean?
56.9.
What's our standard deviation?
7.6.
And what do we get?
0.993.
That's what I got.
Anybody put in something slightly different?
I entered mine in with the negative 9999, and I got a negative 0.993.
So you put them the other way?
I put it in the same order, but instead of the negative 1E99, I did your negative 49.
Okay.
But
So
I
you
came
got-
out with a negative number instead of a positive number.
And that came out negative?
Uh-huh. 7, 5, 6. Yeah, everything's 269 and 7.6. Let me do it again.
And you use the normal CDF, not the inverse?
I think in the calculator, the low value actually goes first and then the high value. So that could be why.
Oh, you mean the negative 999 first?
Yeah.
That's what we wrote on the other problem.
Yeah.
That one goes first. Okay. Let me try
Well, and
that.
I was following this. Oh, it does say low, high, doesn't it? Okay, good. That's what I was worried about. I just wrote high, low here. Low, high. That makes more sense because that's what our number line looks like, right?
Well, it depends on what calculator you have, because my calculator does not give it to me that way. My
Oh, yeah?
calculator automatically gives me my lower, upper, M, and whatever, and it automatically puts in the 1 minus, or the 1E
The negative 1.
in the lower portion.
Yeah, mine's the same way.
Yeah.
Oh, okay,
You
yeah.
guys have you guys have those nice 84s then, right?
Yeah.
I got an old school one.
Yeah.
It's like 15 years old.
I have a
But
TI
yeah, but when I
81 that was a first run from HP or from Texas Instruments in 89
Right.
and it still works and it does all the buttons are a little sticky, but
So if I
So-
put the negative 999 first, like Andrew was saying, then I get the same answer as you guys. Then.
it's having those reversed, the thing just said, okay, that's the orientation's reversed. Here's the reverse value. Yeah. So it tried. I was just writing it backwards. I was kind of curious to see what would happen if it was backwards too, but it just makes it negative. Okay. But yeah, low, high. Okay, that makes more sense. So what does that 99.3 mean? What is the probability that a random child has a height of less than 75.6 inches? 99.3% chance. 99.3% chance of having a height less than, what is that, 6'3.5"? I hope the 6 foot, the 6'3" 10-year-olds are rare. Then I'm asked, what's the probability that a randomly chosen child's height is more than 55? Without doing any work whatsoever, how much about should that be? What's our expectation?
A little bit more than 50%.
So that 56.9 is our mean. The 55 is a little bit less than that. And we want more than that. So yeah, little bit bigger than 50%. I buy that. Is this an inverse problem or a CDF problem?
CDF.
It's a CDF problem.
It's a tricky one.
Tricky one.
Agree.
Well,
Kind
as
of.
you guys said, it's very common for this thing to default to that less than, right? Now, it doesn't have to. We can change that and make that our low value of 55.3 and then make the high positive 1 E99 if we wanted to. But let's say that made you nervous. It doesn't make you nervous?
No.
No?
I get
Okay.
it. I totally get it.
Let's say it did make you nervous.
No.
And you wanted to use the kind of and down logic that we tend to use on everything, right? Just for, sake of argument. Then this would give you everything from the bottom up to 55.3, right? How would we change that to getting the top?
Subtract it from 1.
We'd subtract it from 1. So you could do that if you wanted to.
Yeah.
But again, the nice thing about this particular tool is supposedly we should be able to switch that order automatically. We won't always be able to do that. Not all of our tools will be able to do that. So we want to be used to that and down logic because that's going to be our most common tool. But and I do want to encourage you to use the 1EE99, use that scientific notation tool. It doesn't make much of a difference, as we saw, when we're using a standard normal distribution curve. But as soon as we start using, really big values for our mean and standard deviation, that number has to be bigger and bigger and bigger by comparison. So it is good to get used to using that, EE logic. But on the standard curve, more than 5 was fine. But like here, if we tried to use, like just 9, that 56, it's got to be large in comparison to that 56. There. So putting in what your calculator thinks is basically infinity is a good habit. So where does that spit out?
Um, 0.583 or 58.3%.
0.583, which compares very well to Andrew's more than 50.
Mhm.
So, there's a probability, the probability that a child is more than 55.3 inches is 58.3%.
So when you switch the places on the 1E99, is
Mhm.
you just make it positive then? Is that
Yep.
a rule that you have to? Okay.
Because remember, the our mean is there, right? So this direction is, kind of positive numbers. This direction is eventually zero, but then would keep going into negatives. Conceptually, how can our heights, like when we had the negative 1e to the 99, conceptually, how can our heights be negative? They can't. But we know the probability distribution has a section of negative values on it, right?
Right. Okay.
So the model has them. We want to take advantage of the fact that the model has them. I wouldn't be surprised if you went from 0 to the 55.3 and then subtracted that from 1. If it wouldn't, that answer would change only very slightly. And I'm not sure it would change at all to that many decimal places. Actually, I'm pretty sure it wouldn't. So, no. Wouldn't, I don't think it would change at all. If somebody went, but you can't be shorter than 0. So I refuse to put in negative numbers there emotionally. It's not going to change that answer. Fair? Yeah, really, as long as this is, as we saw up here that 5 to 9 was enough, right? For that high-low. That 5 or 9 was because it was standardized. So that 5 or 9 was 5 or -5, -9 standard deviations. So our standard deviation is this 7.6, right? So if we go 5 of those, say, that's 40 or 50. So if our low is 50 less than this, so if we start at around 5 inches as the smallest 10-year-old we're going to find, that would be plenty. Fair? So if the negatives bother you, just make sure you're 5 or 6 standard deviations below, and that's going to not change stuff. But the -1E99 or the +1E99 is just a nice way to not have to think about that and put in something that is obnoxiously infinity. Questions about those? They do take practice. Make sure you get that practice time in. Tomorrow I want to look at doing this with Excel and look through some nice problems to get some practice with it. We don't have a formal lab on it, but I do have kind of some supplemental questions that we'll put in with your lab stuff. That was that Chapter 7 supplement that we talked about a little bit yesterday. So I'm just going to use those problems and have you use Excel to do those problems and just to see how Excel works with this stuff and to get some more practice with them. I'll probably mix in some Chapter 6 questions with those Chapter 7 questions because next week we have a test on 6 and 7. And it won't say, by the way, this is a Chapter 6 question. By the way, this is a Chapter 7 question. They'll be mixed. So being able to use the idea of this chart to kind of go, okay, which tool am I using and how am I using it is going to be important.
Hey, Matt, have you ever thought to add that question in?
Which question?
I don't know, just a reminder like, hey, which tool am I using? like as a part of your teaching, like on the tests and stuff? Like
I
what
think
problems
that-
are these?
I can always just ask any question, and the first part of every question is what tool. So,
Yeah.
it's on all of them.
What day is the test?
I think it's listed Monday.
Oh, gosh.
I
Oh,
think
but
that's
we
the
can
plan.
take it Sunday?
What's that?
Can I take it Sunday?
If you want to.
Oh, wait, I can't take it Sunday.
No, you can't.
I'm going to Lake of the Woods for Sunday, Monday, and Tuesday.
I don't care about your lives.
I know. Can I do it on Saturday?
If you want to.
All right. I'll miss the review, though, that you're going to have on Monday morning, probably, huh?
Yes. But again, I don't care.
I know. Just
Your
think
life and
out
your
loud.
problem.
Sorry. Ah. Okay, I can do it.
The rest of you, I care a little bit more about. Kimberly,
I know. As it should be.
as you should. Okay. Anything else I can do for you guys before tomorrow? If something comes up, let me know. I think I saw 2 or 3 of you had gone through most of these or questions. A couple of you had started it. Do make sure, though, you try to get into a fair amount of this before tomorrow, because tomorrow is a good day for us to kind of make sure we're happy. So do make sure you find some time before tomorrow to go through, a fair amount of these. Okay? Okay.
Are you going to work on this now?
Yeah. Anybody who wants to stay after, yeah. We'll log out and log back in.
Yeah, I'll log out so it'll start converting the video, but.
Okay.
Okay. I'll see you guys later.
Okay.